Okay, so for anyone out there prepping for those senior software engineer interviews, you know, uh, one thing that always seems to pop up is this whole move from monolithic architectures to microservices,
Hmm.
especially when we start talking about data management.
Yeah.
It's like going from this, one-size-fits-all Swiss Army knife to this whole set of specialized tools, right? You're still trying to achieve the same outcome, but the approach is fundamentally different.
I like that analogy.
Yeah.
Yeah, it's like, imagine back in the day in the monolithic world, you've got your product catalog and your financial transactions all living happily together in a single database.
Right?
You need a bestseller report? No
Yeah.
problem.
Yeah.
You just do a simple database, join, bam. You've got your product details combined with the sales figures.
Exactly. Like, picture this catalog functionality. It's got all the info about our albums, the unique ID, the album name, all that jazz.
Okay.
And then over here, you've got this finance functionality keeping track of every single sale in this big old ledger, right? Noting the SKU and the date it was sold.
Right.
So in a monolith, to generate a report that tells you, okay, what album names are flying off the shelves, you just write a database query.
Right.
You join the ledger table using the SKU with the albums table, using the ID as like a connecting link.
Yep. The schema in the ledger is essentially a pointer directly to a specific album in the albums table.
Exactly. And relational databases, they're beasts at these join operations.
Oh, yeah.
They've been honed over decades to efficiently combine data from related tables.
It's like their bread and butter.
Right. It's like a fundamental database capability that in a monolithic setup, we kind of take for granted.
We do. We absolutely do.
So, okay, let's shake things up a bit. What happens when we blow up that monolith into these individual microservices? Let's say now we've got a dedicated catalog microservice.
Mm-hmm.
It's managing all our album data in its own little albums database.
Okay.
And then over here, we've got a separate finance microservice handling all the money stuff.
Right.
With its own ledger database diligently recording all those sales. Now, the finance microservice, it still needs that bestseller report, right?
Yeah, it does.
It still needs to know what album names are associated with those top-selling SKUs in its ledger database.
Mm-hmm.
But here's the catch: that straightforward database join we relied on before it's gone.
It's out the window.
Poof, vanished, because the album names, they're not sitting in the finance microservices database anymore.
Exactly. This is where things get interesting.
Right, the whole dynamic shifts.
Absolutely.
So the finance service, first it figures out, okay, what are my top selling SKUs? It queries its local ledger database.
Right. So far, so good.
But to grab the matching album names for those SKUs, it has to reach out across the network to the catalog microservice and be like, hey, can you give me this info?
Yep. Catalog microservice gets this request. Goes,
Right.
Okay, let me check my albums.
Yeah.
Database grabs the album name linked to that. SKU sends it back to the finance microservice.
So instead of one clean, efficient database join, we've got this whole song and dance,
A little more complicated.
a query to the ledger database, a network call between these two independent services, and another query to the albums database.
And immediately you start thinking about the performance implications.
Oh, yeah. Network latency rears its ugly head.
Right. Which can be super unpredictable depending on your infrastructure.
Exactly. And it becomes this unavoidable factor.
You know what I find fascinating here, though? It's like the join operation is still happening logically, right?
It is.
We're still connecting sales data with product info. But instead of the database doing the heavy lifting internally, it's the finance microservice orchestrating this join in its application logic.
Right. It makes the initial query, then uses those results to fire off another request to another service.
Like a middleman.
Right. And as you said, this distributed approach, it's generally slower than that direct database join.
For sure, even if each individual database query is lightning fast,
Mm-hmm.
that added overhead of network chatter and the multiple steps involved, they can really introduce latency.
Totally. We could try some clever workarounds, though, right? Like maybe the finance service could request info for a bunch of SKUs at once in a single call to the catalog service.
Yeah, a bulk lookup.
Right. Or we could cache frequently accessed album info within the finance service.
Caching is always an option.
But then we've got to deal with keeping that cache fresh.
Cache invalidation, oh boy, that's a whole other can of worms.
Right. It adds complexity.
For sure.
Okay, so another big thing that this brings up is data integrity.
Oh yeah, this is critical.
Right. In that monolithic world with the albums and ledger tables cozying up in the same database, we could enforce relationships with foreign keys.
Exactly. You could guarantee that every sale record in the ledger had a corresponding album record in the albums table.
Right, and the database itself would stop you from deleting an album if there were still sales records linked to it.
Right, like those database constraints on delete cascade, they were your safety net.
But now with our separate microservices, those direct database level foreign key constraints, they're out the window.
They're gone.
The finance microservices database, it has no clue about what's going on in the catalog microservices database.
It's like they're speaking different languages.
Right. So what's to stop someone from accidentally deleting an album record in the catalog database, even if there are still tons of sales records for that album in the finance database?
You're going to have a bad time.
Right. That bestseller report, it could end up full of holes and inconsistencies.
Yeah, you lose that strong database-enforced referential integrity across those service boundaries.
So what do we do?
Well, development teams have to step up and address this proactively.
Right.
One approach is soft deletes, where you mark records as deleted instead of actually wiping them out.
Okay.
Another option you mentioned earlier is copying the album name into the ledger table right at the time of sale.
Yeah, but then you've got to keep that duplicated info in sync if the album name changes later.
Exactly. It's a trade-off, more complexity.
Right.
But hey, that's the microservices world for you.
And it doesn't stop there, does it?
Nope.
What about transactions?
Yeah, good point.
In the monolith, if you needed to update order details and adjust inventory counts at the same time, you could wrap those operations in a single ACD transaction,
Right.
guaranteeing that either both operations succeeded or both failed, keeping your data nice and consistent.
ACD was your best friend.
But now, with each microservice having its own separate database, those classic AC transactions that span multiple databases, they're off the table.
They just don't work in this context.
Right, so we need to explore other options like sagas.
Sagas are interesting. They're like choreographed sequences of local transactions within each service.
Okay.
But they often introduce this concept of eventual consistency.
Meaning?
It means the overall system state might be temporarily out of whack before all those local transactions finish and everything settles down.
So it's a different way of thinking about data consistency.
Absolutely. It's a shift in mindset.
And let's not forget the operational side of things, managing those database schemas.
Yeah, that gets trickier too.
Instead of one database schema, you've got multiple independent databases potentially changing at different rates.
Right, driven by the needs of their respective microservices.
So you can't just run a single database migration script across the whole system anymore.
Nope, you need new tools and processes.
Right. Teams often rely on things like version-controlled Delta scripts and tools like Flyway or Liquibase to handle these independent database schema changes.
They help keep things organized and consistent.
Okay, so you've talked about the challenges, right? We've gone from this relatively simple database joined in the monolith to this world of inter-service communication performance bottlenecks and the complexities of maintaining data integrity and consistency.
A lot to think about.
So what are some architectural patterns we can use to navigate this tricky landscape, especially when it comes to reporting?
Oh, this is where the reporting database pattern comes in handy.
Okay, let's dive into this reporting database pattern. What's the main idea?
So the core concept is that each microservice takes on the responsibility of populating one or more external databases that are specifically designed for reporting.
Okay.
Let's go back to our example, the catalog microservice. It might publish relevant album information to a dedicated reporting database.
Right.
At the same time, the finance microservice might push its sales data, maybe already aggregated or transformed into a format that's easier to use for reporting, into the same or a different reporting database.
So this reporting database, it acts as a central hub where we can run our reporting queries. And if the data from the different services has been combined in a way that makes sense, we can even perform joins within this database.
Exactly. And this reporting database is built for external access. It's tuned for those heavy-duty reporting workloads.
Right.
It might even use a completely different database technology that's better suited for analytical queries.
Interesting.
And a big advantage here is that it hides all the messy details of how each microservice stores and manages its data internally.
It's like a clean interface.
Exactly. The reporting database only exposes the specific data that's needed for reporting, nothing more.
Okay, so when the finance team wants to generate that bestseller report, they don't have to go poking around in the catalog services operational database or try to do some crazy joins across live service data.
Nope, they just query this dedicated reporting database.
Which ideally has all the info they need, the sales figures, the album names, all ready to go.
Potentially even already joined or structured for efficient reporting.
This seems like a pretty elegant solution.
It has its benefits for sure. It allows for efficient querying and joins in an environment that's built for reporting. It lets you tailor the schema of the reporting database to fit specific reporting needs.
Top.
And importantly, it lets external systems or users access reporting data without putting extra strain on those operational databases that are crucial for the day-to-day functioning of the microservices.
Right, because those need to be kept running smoothly.
Absolutely.
It also reinforces that idea of information hiding, doesn't it?
Oh, yeah. Definitely. The internal data structures and operational details of the catalog and finance microservices, they stay hidden.
Right.
The reporting database only reveals what's explicitly meant for reporting.
So to wrap things up, we've seen that moving to microservices brings about a significant change in how we handle data.
Hmm.
We lose the simplicity of in-database joins and have to deal with the complexities of inter-service communication, which can impact both performance and data integrity.
Right, there are trade-offs.
But architectural patterns like the reporting database give us a way to address the need for integrated data insights
Yeah.
while still keeping our individual microservices independent.
Exactly. And these are crucial concepts for anyone aiming for a senior software engineering role.
Absolutely.
Having a solid grasp of these trade-offs and the architectural patterns we use to tackle the challenges of distributed data management, it's fundamental for system design in a microservices world.
But like the foundation.
It is. And, there are other approaches too, like API composition, where the finance service might directly call APIs on the catalog service to fetch the data it needs for reporting.
Right.
Each approach has its own set of pros and cons in terms of complexity, performance, and data consistency.
For sure.
Like API composition can sometimes lead to tighter coupling between services.
Okay, so for all of you out there gearing up for those technical interviews, here's a final thought to ponder.
I like it.
As you're designing systems in this brave new world of microservices, how will you strike that balance between data independence for each service and the need for those big picture data insights?
It's a balancing act.
What are the key factors that will guide your decision-making process when you're choosing between doing joins at the service level through API calls versus setting up a dedicated reporting database? Lots to consider. That's all the time we have for this deep dive. Thanks for joining us.
It's been a pleasure.